Good evening, dear students. That day we had done about the human eye, power of accommodation. In power of accommodation, there are two things to be kept in mind. There is what we call the near point and the far point of the accommodation of human eye. The near point is the point at which the human eye can see distinct object clear and the image formation is distinct to the brain. The farther point is the maximum distance to which human eye can see. The near point is minimum 25 centimeter in case of adults, and in case of child it should be around 7 to 8 centimeter. And the farthest point is infinity, but the clarity is not as in case of the farthest point. Now, what is exactly near point? The minimum distance from the eye at which the object can be seen clearly is called the near point. The minimum distance from the eye at which the object can be seen clearly is called the near point of the eye. Next is the distance is also called the least distance of distinct vision. The least distance of distinct vision. That means we can see things exactly clear at the least distance. Anything which comes closer to that one becomes blur, not exactly clear. The near point of human eye varies from person to person and also with age. For example, a young adult with a normal vision, the near point is about 25 centimeter, and for a child of age below 10 years is approximately 7 to 8 centimeter. Now, to find out the near point, what are we going to do? We know that the image distance and object distance that we used in the lens formula, U stands for your object distance, V stands for your image distance, and F stands for focus. Now, for the near point, the object distance from eye lens, that is, we have taken U as minus 25. Why minus? Because it is away from the lens. Image distance, that is the retina, the distance of the retina from human eye to retina is approximately 2.5 centimeter. That is 2.5 centimeter. So the image distance is fixed. Object distance, as we are taking minus 25 here in this case, to find out the nearer distance. So using the lens formula, you take 1 by f is equals to 1 by u. If you take 1 by u plus 1 by v, that is what lens formula we use it. We are going to use the lens formula as 1 by f is equals to 1 by v minus 1 by u. That is 1 by 2.5 minus 1 by minus 25. 1 by f is equals to, it will be 10 by 25 to change the 2.5 decimal plus 1 by 25. Now it becomes 11 by 25. That is 1 by f is equals to 11 by 25, or f is equals to 25 divided by 11. That will be approximately 2.27 centimeter. If you convert that into meter, since focal length is always counted in meter, it will be 0.0227 meter. 227 meter. I will be showing you the sums. Sums part I will be showing you in the board, that you will be seeing how the numerical deduction is being done. Then this is the shortest focal length of an eye. Now to find out the power, we know that power is 1 by focal length. So 1 by focal length, that is 11 by 25 into 100. Because we are converting into meter, the centimeter is converted into meter. So it will be, power will be 44D. Thus the power of the eye lens is 44D when it focuses the nearer point, that is 25 centimeter in front of the human eye. Next we talk about the farthest point or the far point. Now when we talk about far point, it depends upon, again as I say, the farthest point upon which the eye can see the object clearly is called the far point of the human eye. For the normal eye, the far point is at infinity. Thus a normal eye can see the object clearly when placed between 25 centimeter and infinity. The distance from 25 centimeter to infinity is called the range of normal eye. But again with the age, again with the problem with the eyes, or it could be because of misfortunes, accidents, deficiency, disorders, there could be some changes in this one, and it can be rectified with certain help of the lens. When the eye lens is focused at the far point, the ciliary muscles are most relaxed. In this state, the focal length of eye is maximum and the converging power is minimum. Focal length, the focal length, that is the length of the eye lens, is maximum, and the converging power is minimum. For objects, we can take u, which is, as we said, object distance. U will be infinity. Image distance, again it will be 2.5, as the distance from the eye lens to the retina is 2.5 centimeter. So again, if we use the lens formula as it is, 1 by f is equals to 1 by v minus 1 by u, we get it 1 divided by 2.5 minus 1 by infinity. That is 1 divided by 2.5 or 10 by 25. Or 1 by f is equals to 25 by 10 or 2.5 centimeter, which can be converted into meter as 0.025 meter. Now the power, P is equals to 1 by f. 1000 divided by 25. So we get it 40. We get 40D. Now, thus we see the power of the eye lens varies from 40D to 44D. The difference in the power of lens between the nearer point and the far point is 44D minus 40D is equals to 4D. This variation in power of lens is called power of accommodation. The power of accommodation of the near point and the power of accommodation of the farthest point. Both the powers if we minus, we get 4D as the difference, and this variation is called the power of accommodation of human eye.